Hello students, wish you all a very happy new year 2021. How are you? Yes, I hope you enjoyed last night. So that is why I shifted last night. Actually, I planned to take this class during midnight, but so I thought all of you are maybe busy with your New Year celebration. So I shifted this class to New Year Day, that is January 1st, and it is, I hope already you woke up and did your ablutions and all. You are set right now. And very important notice students, all of you, those who are preparing for board exams and JEE NEET. So CBSE board has declared the new dates for your board exams, and exams are going to be conducted during May 2021. So be serious about your board exams, and your session starts now itself. So very short, time is very short, running out of your control. So get ready with all your weapons and be ready with all your preparations. So this time it is going to be held during May, your board exams. Yes students? Dear students, I wish you all a very happy new year, and especially Venus Academy viewers, dear students, friends and relatives and those who helped me to achieve the big goal of 23,000 subscription students. So I am very much happy to declare that Venus Academy achieved a huge response from the viewers and it reached 23,000 subscribers. Yes students, I am thankful to all the subscribers and viewers, and I hope you will continue the same support by watching these videos. And dear students, please write your comments and don't forget to like the videos. And if you like it, you can share with your friends or relatives, whichever is suitable to the friends. Dear students, I request all of you, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Yes, are you ready? We are going to start the lecture. Dear students, welcome to the series of organic chemistry lectures. In previous lecture, under aldehydes, ketones and carboxylic acids topic, we have completed aldehydes and ketones, their preparation and properties. Today we are going to learn carboxylic acids, their preparation, physical properties and chemical reactions. Yes students, so while this session is going on, since it is a live session, if you have any doubts regarding this topic or previous lecture, and you can write in comments box. Yes students, welcome to the series of organic chemistry. Today we are going to learn carboxylic acids. What is carboxylic acid? Carboxylic acid is an organic compound which is having carbonyl carbon attached to hydroxy group. So this carboxylic acid hybridization is sp2 hybridization. Since it is sp2 hybridization, it is going to have the bond angle is 120 degrees, and it is going to have 3 sigma bonds, 1, 2 and 3 sigma bonds and 1 pi bond. When it comes to the shape, it is sp2, so trigonal, planar or coplanar. So it is a planar molecule, and it is attached to carbonyl carbon, carbonyl oxygen and hydroxy group. It is resonantly stabilized because it is attached to electron withdrawing group oxygen to two sides. So it is going to have partial positive charge and it is going to have partial negative charge. So where this oxygen pulls this double bond electrons towards it to make this carbon electron deficient. However, it is going to be resonantly stabilized by the lone pair electrons which are present on this oxygen So these are the resonance structures of carboxylic acids. Because of these resonance structures, carboxylic acids are stable compounds. Let us see some carboxylic acid compounds. Yes. So the common carboxylic acids we come across, it is carboxylic acid structure. And if this hydroxy group is substituted with halide, we say acyl halides. And if it is substituted with amide, we call it as amide. It is acid. If this is substituted with OR group, it is known as ester. And this, if it is substituted or having another molecule of acyl group, then it is known as anhydride. So these are usual forms of carboxylic acids where you will find this carbonyl group common, and these are all the derivatives of carboxylic acids. So amide, acid, acyl halide, amide, ester, anhydride. So these are the common names we come across during the preparation and chemical reactions of carboxylic acids. Yes students, let us see some common carboxylic acids we come across in laboratory or during the chemistry of carboxylic acids. The names are very important to learn. So the starting carboxylic acid is, what is the name? Formic acid. Write down the acid's name students, very important. Methanoic acid. This is the common name and it is IUPAC name, and this is the structure. Yes, so this hydrogen, as I go on increase, CH3 OH, what is the name? Acetic acid and ethanoic acid. Yes students, and if I increase further, this is propionic acid, common name is propionic acid. And what is this acetic acid? Acetic acid is vinegar, where you will use as a food additive which gives sour taste. Yes, propionic acid, acids are sour taste. The IUPAC name is propanoic acid. And if I increase this CH3, CH2, CH2 and COOH, it is butanoic acid or butanoic acid and butanoic acid. When I increase further, the name is very important students. The common name is valeric acid. Pentanoic acid is also known as valeric acid. Yes, so these are carboxylic acids based on the names are given based on the alkane chain. So if it is one carbon, methane or methanoic acid, it is ethane, ethanoic acid, propane, propanoic acid, butane, butanoic acid, and pentane is valeric acid common name, and pentanoic acid it's IUPAC name. Then let us see some dicarboxylic acids. The The common dicarboxylic acid we come across is this is oxalic acid. The names are very, very important, students. Oxalic acid, ethane dioic acid, if I increase OH, what is this? Malonic acid. This is propane dioic acid. If I increase further, the chain is going to be increased, students. So this is succinic acid. Butane dioic acid. And when I increase further, this is glutaric acid. Pentane dioic acid. And very, very important acid in this series is hexane. Is it visible, students? Hexane dioic acid and the common name is adipic acid. So where do we find this adipic acid? Adipic acid is a very, very important synthetic compound where it is finds use in the preparation of nylon 6,6. So during polymers I am going to explain. This is adipic acid. 6-membered carbon dicarboxylic acid is adipic acid. So how to remember the names of these compounds? So these are no doubt methanoic acid, ethanoic acid. Based on IUPAC you can remember. Formic acid you have to remember. Acetic acid, common name is vinegar. You will get this vinegar or acetic acid in different forms. What is the acid used in food additive as food additive? Is it vinegar or some other acid? Propionic acid, butanoic acid, uric acid. When it comes to these dicarboxylic acids, it finds very important reaction intermediates and synthetic starting materials during name reactions and further studies. Right? So these dicarboxylic acids names can be remembered or by heart, or you can easily write down somewhere based on the starting alphabet. So what is this? O, M, S, G, A. So it is written as O my such great apple. So you can abbreviate in the way, whatever the way you want to write. So this is common. So oh my such great apple is dicarboxylic acid. So O stands for oxalic acid, M stands for malonic acid, then succinic acid, glutaric acid and apple. This is the way you can remember these 5 acids. So these are very, very important dicarboxylic acids where you come across number of times during the synthetic organic chemistry. Yes, students. So another important tricarboxylic acid is there. That tricarboxylic acid is citric acid. Let us see what is citric acid. CH CH2, CH2, CO2H, CO2H, CO2H. This is 1, 2, 3 propane, 1, 2, 3 tricarboxylic acid. So if you remember this structure, it will be easy to write down the structure of citric acid. So it is alpha hydroxy propane 1, 2, 3 tricarboxylic acid. It is citric acid. What is the common name? Citric acid found in citric fruits. Yes, student. So citric acid commonly used as food additive, but the question will come like this: what is vinegar? Is it citric acid or acetic acid? Vinegar stands for acetic acid. Yes, students. So citric acid is tricarboxylic acid having hydroxy group. So this is how carboxylic acids finds very important role in food industry as well as synthetic organic chemistry, soaps and other compounds, where I am going to explain uses of some carboxylic acids at the end of this topic. Let us see the preparation of carboxylic acids. Yes, students. Preparation of carboxylic acids. So the first and foremost method is oxidation of alcohols. Again stands, what is oxidation? Reagent. So lending of electrons is oxidation, gaining of electrons is reduction, or in another form, addition of oxygen is an oxidation. So if I add oxygen to a molecule, then that reaction is going to be oxidation. So oxidation of alcohols. If I take alcohol, RCH, and this is alcohol, and it is primary alcohol. When I do alkaline KMnO4, alkaline means basic, or NaOH or KOH you may write, or I can write KOH. Let me write KOH. In presence of KMnO4, potassium permanganate, it is going to give carboxylic acid. So it is going to be added a new. So we are going to get this carboxylic acid from alcohol by using potassium permanganate. What is the mechanism? Dear students, it is very easy. Since we are using base, so it abstracts this proton minus water to give R. These two hydrogens are there, and oxygen, primary alcohol, students. This is oxygen minus now. This minus oxygen is going to add to MnO4. MnO4 is KMnO4 when it loses potassium. I can write potassium here, positive and O minus. And this is KMnO4, and this comes and adds to here to give an intermediate of C, hydrogen here, O, and this hydrogen is here, manganese. This mechanism is very, very important, students. O, I can write this negative charge here, and this double bond and O minus. And now what is going to happen? It is going to, this proton is going to be picked up by this oxygen and it comes here, and this bond will be back to manganese to give, it is going to lose as HOMO3 MnO3 O4, and it is going to give aldehyde. This is aldehyde is going to be an intermediate. Yes, students. So this aldehyde further reacts with HOH, or we are going to have OH in the reaction mixture. To give RO minus, let me write hydrogen upside, and this is OH is downside, this OH, right? Now it reacts with another molecule of MnO4 where O, K minus, and this is, it is going to attack onto this to give, let me write the structure, RCOH, it is there, O manganese, and hydrogen is here, O minus, O minus, right? Yes, plus 7. So now this is going to lose, taken up by this hydrogen, by this, and it is going to form double bond, and it is going to form this minus HMnO4, and it is going to give acid, right? So let me write R, this OH, and now double bond O. What is this? This is the acid we are going to get. So oxidation of primary alcohols going to give acids. So this is the mechanism where manganese KMnO4 is going to act as oxidizing agent. So please write down the mechanism if you want. Take the screenshot. Yes. So we are going to get carboxylic acids. Then another method, Jones reaction or Jones oxidation. Let us see the oxidation of primary alcohols with Jones reagent to give carboxylic acids. Yes, students. So oxidation of alcohols, Jones reaction. So Jones reaction or oxidation. So the reagent is chromium trioxide. It is a solid, students, will be dissolved in aqueous sulfuric acid to give yellowish red color solution or orange red color solution. Going to have chromic acid. So this chromic acid oxidation state is +6. Chromium is in +6 form. This chromium trioxide or chromic acid is going to be added. This solution is going to be added to alcohol in acetone is a solvent. Yes, student. So primary alcohols in Jones reaction. So this is the active species. In reactions you will get like this: R CH2OH primary alcohols, chromium trioxide, sulfuric acid in presence of acetone, you are going to get acids. Whereas secondary alcohols, if it is secondary alcohol, chromium trioxide, sulfuric acid, same acetone, you are going to get ketone. This is ketone. Yes, I have explained during aldehydes and ketones topic. So primary alcohols are going to give carboxylic acids. Let us see the mechanism of this oxidation of alcohols to carboxylic acids. So it is very simple, students. I can write this as hydrogen. So this is primary alcohol in presence of chromium trioxide. This chromium trioxide is going to form this chromic acid. This chromic acid is going to since it is in acidic form, yes, so it is going to react with this, and this water is going to be out. Minus water, we are going to get R, hydrogen, and this oxygen, now chromium complex. OH is here, double bond O, double bond O. Yes, students. So this at this stage it is going to taken up this proton by this oxygen to form what is the oxidation state here? 6. RCOO hydrogen, and plus here chromium is going to be OH and OH, and this is chromium 4 complex is going to be out. So this is the aldehyde. So even aldehydes also oxidize to direct carboxylic acids if you have aldehydes in your hand. So the intermediate is aldehyde is going to be formed. However, it is very tough to isolate at this stage. It immediately reacts with chromic acid which is there in the reaction mixture to give direct carboxylic acids. Yes, if it is R group here, R is ketone. If it is R here in place of hydrogen, if it is R, we are going to get ketones. Right, students? So this is aldehyde. Aldehydes further are going to react with chromic acid and to give carboxylic acids. So what is there in the reaction mixture? We have HOH, which is water, aqueous solution. So this water is enough to add to this O, where in presence of acid this takes a proton to give this positive charge. Oxonium ion takes up like this to give R, OH and OH. It is hydrogen. Now what is there? This is going to react with chromic acid. So chromium, OH and OH. This OH and chromium is going to be out as acid water to give an intermediate R. COH is here, O. Dear students, I am going slowly at this stage because this mechanism is not available in Googling. So it is very tough to get this. So I am writing in detail. So in a short and very easy manner to understand. So this 6 complex is going to form chromium, OH and now this is chromium oxygen. At this stage again what is going to happen? It is going to pick up this oxygen, this hydrogen, and now it is going to form this, and it is going to lose minus chromium 4 complex, O minus, or this hydrogen already has come, OH, and this carbonyl group is here, and this is R, C, and oxygen double bond O. For your understanding, I will write R, C, OH is here, and this is double bond O. So this is carboxylic acid you are going to get straight. So this is the mechanism of oxidation of alcohols to carboxylic acids. Primary alcohols gives carboxylic acids. If you want, please take the screenshot of this. Yes, students. Let us see very important reactions where you will get from alkyl benzenes to benzoic acid. Yes, students. So what is benzoic acid? This is benzoic acid. How to get this? You can get it from, let me write for example toluene in presence of KMnO4. Yes, so it can be obtained from any chain, doesn't matter, CH2, CH3, ethyl benzene, KMnO4, you are going to get benzoic acid. Isopropyl benzene, it is cumene. Cumene upon oxidation using KMnO4. Dear students, COOH will be here in all cases. Alkaline COOH, right? COOH, you are going to get benzoic acid. And for your understanding, cumene upon oxidation followed by hydrogen peroxide and NaOH, what we are going to get? We are going to get phenol, cumene hydroperoxide rearrangement reaction. We learned this, phenols, under phenol chapter. So this type of questions you may get, right? Cumene in presence of KMnO4 and KOH, we are going to get benzoic acid, right, students? So if it is oxygen and hydrogen peroxide, you are going to get phenol. So primary, we are getting acid. Secondary, we are getting acid. Whereas if it is substituted further, so this is, I can write like this, and if it is substituted with another methyl group, so if there is no hydrogen, benzylic position, this is benzylic position, no hydrogen, no benzylic hydrogen, there is no oxidation. KMnO4, no oxidation. It is very important, students. So if it is tetra substituted, no hydrogen, I can say whatever is the substituent, if there is no hydrogen, there will be no oxidation to KMnO4. Dear students, whatever may be the chain, a big chain also gives benzoic acid. It simply breaks here. So oxidative degradation of alkyl benzenes, oxidative degradation of alkyl benzenes gives this benzoic acid. Yes, so if the alkyl benzene is like this, yes, what is the product? Guess. COOH and KMnO4. If I add KMnO4 in presence of base, what is the product I am going to get? I am going to get, so what I said, it is going to break here and here to give benzene dicarboxylic acid, 1,2-dicarboxylic acid. So this is benzoic acid, this is benzene 1,2-dicarboxylic acid. Its common name is phthalic acid. Yes, so phthalic acid can be prepared starting from this tetralone. It is tetralone. Upon oxidation using KMnO4, you are going to get phthalic acid. It is a one-step method to get this phthalic acid. This is how you can prepare carboxylic acids from alkyl and alkyl benzenes. Important thing to remember is tetra-substituted, no alpha hydrogen containing compounds are not going to oxidize to benzoic acid. It has been appeared in every JEE mains exam. Yes, it is damn sure question. Yes, students. So the examples will be given like this. Whatever may be the chain. If you have cumene, yes, you can get benzoic acid only. There will be no other substituent. Simply it goes out and it is going to give benzoic acid. However, if it is substituted with 3 carbons and there is no hydrogen, you are not going to get this carboxylic acid. Then what is the importance? Very simple, students. During the previous alcohols examples, the first step where the hydrogen is going to be picked up by base. So this hydrogen is highly acidic. It will be picked up by OH, that is KOH, what we are going to get use as water to give benzylic carbocation. This benzylic carbocation is stable, so it forms very easily. That benzylic carbocation will be oxidized by MnO4, where O- will attack onto this, and remaining chemistry is similar or same to alcohol's chemistry or mechanism. That is how. So presence of hydrogen is important to prepare carboxylic acids at benzylic position. Next, from nitriles or amides. So what are nitriles or triple bond N? Nitriles, how to get these nitriles? During haloalkanes I have explained. So alkyl halides reacting with, let me write, sodium cyanide, we are going to get nitriles. So this elongation we are going to get. So 1 carbon extra we got from cyanide. This alkyl nitriles in presence of acid or base hydrolysis are going to form amides as an intermediates. These amides further reaction with acid or base in the same reaction mixture water, we are going to get acids. Yes, students. So this triple bond is going to be oxidized to amide. Amide is going to be give as acid. So this is how you can prepare. For example, if I take acetamide, this is acetamide, and treat it with acid hydrolysis, and upon heating it is going to form CH3 COOH. What is the name of this? Write down. And if I take benzamide, benzoic acid, amide is benzamide, and when I do hydrolysis CSO in presence of this acid, I am going to get acid. Yes, so benzoic acid. These nitriles are very, very important, students, where we are getting our alkyl halides or alkyl aryls or haloaryls. So getting these amides, once you are thorough, then you can get carboxylic acids. This is the way you can get one carbon extra. One carbon extra follow via cyanidation followed by oxidation or oxidation by using acid or base hydrolysis to get this carboxylic acid. This is one of the methods for the preparation of one carbon extra carboxylic acids from alkyl or aryl halides. Next, from Grignard reagent. Yes, so Grignard reagent is alkyl magnesium halide or aryl magnesium halide. Alkyl or aryl magnesium halide is a Grignard reagent. How to get this? Where do we get from? Yes, it can be obtained from R alkyl, aryl, R equal to aryl or alkyl group. Upon reaction with magnesium in presence of diethyl ether or ether, dry ether, or you may get it tetrahydrofuror. It has been given in JEE Mains 2019. THF, tetrahydrofuror. It is cyclic ether. Yes. So in higher exams or higher level exams like IIT JAM or CSIR NEET, you are going to get THF. This is tetrahydrofuror. So you are going to get alkyl magnesium halide. This alkyl magnesium halide, what is the charge on this alkyl group? It is going to have negative charge, and magnesium is going to have positive charge. To give, when I treat it with this carbon dioxide, what is carbon dioxide? It's a dry solid. Yes, dry ice, we can say dry ice. Solid carbon dioxide is also known as dry ice. So this dry ice, when I add dry ice with this Grignard reagent in ether to the same reaction mixture, it is going to form this. So R O MgX, and this double bond is already here. When I do the hydrolysis next, so since I am getting this magnesium salt, once I do the hydrolysis, usually acid hydrolysis or work up with H plus, I am going to get OH, and here magnesium hydroxide, magnesium OH and X. So this is from Grignard reagents, is one of the methods for the preparation of carboxylic acids. And one more important method for the preparation of carboxylic acids is from acyl halides. From acyl halides. What are acyl halides? At the beginning I have said are acid halides. For example, if I write chloride and do the hydrolysis in presence of H plus, that is H plus and O, acid hydrolysis, I am going to get RCOOH plus HCl I am going to get. Yes students, so the same reaction if I do in base OH and in water, I am going to get RCOO minus plus this chlorine minus is going to be obtained. So when I chlorine minus, usually base will have some metal, that is sodium hydroxide or potassium hydroxide. It is going to be like KCl. Let us take potassium hydroxide. Now I have to do again acid hydrolysis. H3O plus, I am going to get acid. I am writing this intermediate because sometimes it is going to be written as given as intermediate itself. So you are going to get anion. or O minus instead of direct acid when I use base. So that is why I am writing, students. Next, or I can use anhydrides. If I use acid anhydrides, for example, it is from acyl halide and from anhydrides. Anhydride. So how to prepare, I will explain during the chemical reactions. Anhydride, preparation of anhydride. Let us take this is benzoic acid and it is anhydride of benzoic acid. Right? So when I do the hydrolysis in presence of water or acid or base, I am going to get, so this is going to get as, for example, acid plus H and O. This is H plus and OH minus. It is going to take up this proton here and it is going to form two benzoic acids. Yes, so this is one and remaining, this is what is there, it is going to attack by OH on this to get carboxylic acid. So this is how you are going to get 2 moles of carboxylic acid or benzoic acid from benzoic anhydride. And if the anhydride is mixed anhydride, mixed anhydride means one acid group is, suppose here I have taken CH2, CH3. Yes? Or let me write estamide itself. So estamide. Benzoic ethanoic anhydride. Upon hydrolysis or H plus hydrolysis, I am going to get benzoic acid from benzene pot, and this is acetic acid, CH3 COH. Dear students, acetic acid can be written as ACOH. Yes, ACOH. AC stands for CH3CO. Please remember, AC stands for acetyl group, CH3CO. So this is how you can prepare carboxylic acids from Grignard and acyl halides and anhydrides. And what else? You can prepare from esters also. Preparation of carboxylic acids from esters. So what are esters? We are going to learn there. From esters, it is one of the methods for the preparation of carboxylic acids. Let me take ethyl benzoate. This is ethyl benzoate. It is very, very important, students, to learn the mechanisms or to know the where we are getting it. So ethyl benzoate, ester is ethyl ester. This is ethyl benzoate. You make it like this. When I do hydrolysis or in presence of acid H plus hydrolysis, I am going to get benzoic acid. It is going to break here. To get benzoic acid, during alcohols chapter I have explained how to make esters, right? Benzoic acid from this part and it is CH3 and CH2OH. Yes? So alcohol I am going to get. In place of acid, yes, I can use, do you want mechanism? I can explain. So here first this takes a proton here to get, let me write. So H plus, it takes a proton to get OH, it is positive, and O, I can write ET here, and when it goes up, the water molecule which is there, OH, it attacks onto this to give COOH, and OH is here, and OET. Yes, students. So now it is coming out OET minus. OET minus, and it is benzoic acid we are going to get. So the beauty of this reaction is, so since it is in reaction, H plus is there, it takes a proton and it forms ethanol. So the beauty of the question comes like this. So what this oxygen, where it is going? If it is labeled with isotopic oxygen, and whether this oxygen is coming into here or here, which is correct? Here it is correct. It is coming with alcohol part. It is not with acid part. Yes, students. So this is how you may get question. So if it is labeled, you are going to get it on alcoholic part. Next, same base hydrolysis. If I do the hydrolysis with base, or let me take other example where this is ethyl butanoate, CH3, CH2, CH2, and this is acid, butanoic acid, and here ethyl ester, CH2, CH3. So ethyl can be written as this. So this is ethyl group, I can write it as ET also. So in presence of base, OH, base is OH minus, isn't it? And water will be there. Base hydrolysis, acid hydrolysis or base hydrolysis, I am going to get, this time since I am using base, let me use COOH or sodium hydroxide. CH3, CH2, CH2, COONA. Since we are taking potassium, we are going to get potassium salt of acid plus ethanol. I can write ETOH, ethanol. So the same ethanol here, the same ethanol, ETOH, ethanol. And this upon H plus S3O or acid hydrolysis, it is going to form butanoic acid. So these are all the methods for the preparation of acids. Yes, students. So you can prepare in these 6 methods where you can prepare from alcohols, from alkyl benzenes, nitriles, amides, from Grignard reagents, acyl halides, anhydrides, and from esters. Yes, students. So this is preparation of carboxylic acid. Let us see the physical properties of carboxylic acids. So what are the physical properties commonly we come across? Physical properties of carboxylic acids. So when you look the acids starting from formic acid up to butanoic acid, these are all liquids and soluble in water. Yes, so these are up to butanoic acid or liquids, that is formic acid, acetic acid, propanoic acid and butyric acid are liquids, and these are soluble in water. And when it increases its molecular weight, as molecular weight increases, these are going to be semi-solids or wax-like compounds, and the solubility decreases. Yes, sparingly soluble, or maybe sometimes they are not at all soluble. So this is semi-solids. And when it comes to, these are aliphatic. When it comes to aromatic carboxylic acid, the starting carboxylic acid is, this is benzoic acid. I can write anywhere, students, benzoic acid, and it is insoluble in water at say 0 degrees centigrade. In cold water it is not soluble, and this benzoic acid, which is starting carboxylic acid of aromatic carbons is benzoic acid. It is solid, pale yellow crystalline solid. This solid is melting point is around 121 degrees centigrade, and it is used as a primary standard to calibrate your thermometers. So it is a practical information, students. So benzoic acid used as a primary standard for the calibrating thermometers. Yes. So its melting point is standard melting point. If the thermometer shows this melting point, if you take benzoic acid, and then that thermometer is going to be correct or calibrated. If not, it will be calibrated as per the melting point shown by that thermometer. Anyhow, so this is different. So it is going to be solid. And very, very important thing is that carboxylic acids, it is important with respect to JEE and NEET students. Carboxylic acids, boiling points or melting points are higher than what we learned till now. Higher than hydrocarbons. Yes, then alkyl or aryl halides. So it is some exemption. Halides, ethers. What else? Yes, carbonyl compounds. Ethers, carbonyl compounds, and especially alcohols. So acids boiling points are higher than alcohols. Just remember like this. Acids boiling points are higher than alcohols. Why? So these carboxylic acids are going to have intermolecular hydrogen bonding, which is very high in nature. That is very high because of its resonance structures. Carboxylic acids will be dimer in the form, whereas alcohols also have a hydrogen bonding, but they are not going to be that strong. Yes, students. So let me take one carboxylic acid. This is carboxylic acid, and it is going to have intermolecular hydrogen bonding where carbon O and hydrogen and H. So it is going to, this is hydrogen bonding, and so it is a dimer of because of hydrogen bonding. Carboxylic acids exist in vapor state of this dimer form. Yes, most of the acids will exist as dimer form because of hydrogen bonding. Yes, so because of this tight hydrogen bonding, two-way, see, this is with this and this is with, so two hydrogen bonds are possible in two molecules of carboxylic acid. So it is tightly hydrogen bonded. So irrespective of concentration, this hydrogen bonding is going to exist, and it is very strong when compared to alcohols. So that is why the boiling points of carboxylic acids are higher than the alcohols. So these are the important points of physical properties, students. Then chemical reactions. Let us see the chemical reactions. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Let us see the carboxylic acids chemical reactions. Yes. So carboxylic acids are very acidic compounds which form salts with metals and bases. Benzoic acid, let me take benzoic acid. When I treat it with sodium metal, it is going to form sodium benzoate. So this is salt, sodium salt of benzoic acid, sodium benzoate. Okay? So this is salt can be formed using sodium metal. and it can form, let me take it as any acid, not only this carboxylic acid, any acid, and it can form salt with NaOH to form this ONA plus water. Yes, students. If I use sodium bicarbonate, it is very important. Carboxylic acids form salt with weak bases also. When it comes to phenols, phenols react with only sodium hydroxide, strong base, and form salt. Whereas phenols will not form salt with sodium carbonate or sodium bicarbonate. Right? It is the distinguishing test for the acids and phenols. Phenols, write down, phenols will not form base with or salt with sodium carbonate and sodium bicarbonate. Phenols form salt with only strong bases like NaOH and COOH. Whereas carboxylic acids forms with even weak bases, that is sodium bicarbonate, sodium carbonate, and strong bases also. Right? So it forms salt with sodium hydroxide, and I can use sodium bicarbonate, which is a weak base, and say it is water, aqueous solution, or whatever it is. Right? I can form or isolate this sodium salt of acid, plus it is carbon dioxide, and what is left over? Water. This is going to be the reaction. And carboxylic acid not only forms salt with just bases, it can dissociate into ions even in water itself. Let me write dissociation of carboxylic acid in water. It dissociates or it loses H plus ions to water to give H3O plus this is the carboxylic acid part, which is anion, and it is resonantly stabilized. Why it loses hydrogen even to water? Because it is resonantly stabilized. So since it is losing hydrogen, it is going to be stable. It loses H plus ions easily to water. So what is the resonance stabilization? It stabilizes like this, right? R O minus and here O. I can write these two structures in one form, RCOO. So it is resonating this anion, right? So this, when I put it in an equation, right? So the constant, if I take dissociation constant, so since it is equilibrium, I can write the constant as K equilibrium. It is nothing but it is H3O products RCOO minus by the reactants, right? So what are the reactants? Water and carboxylic acid. Since water is used huge amount or it is infinitesimal hydration or dissolution takes place with respect to acid, it can be brought here to give equilibrium, and when I bring water here, it is going to be dissociation of carboxylic acid OO minus, and it is RCOOH. And this equilibrium at equilibrium, so the dissociation of carboxylic acid is equal to dissociation of acid Ka, right? So I can write this whole equation as Ka, or Ka equal to, since the dissociation of carboxylic acid is very weak acid, so it can be log values I can take. So if I apply log to both the sides, I am going to get pKa values. pKa equal to minus log Ka. So this is the equation I am going to get upon from this dissolution constant equation. What is this P? P is derived by Fehling, scientist Fehling. So it is a pKa values. The acidic strength of carboxylic acid are mentioned with respect to pKa values. Yes, students. So the pKa values, important thing, students, as the pKa values are, since it is negative logarithm, are low, small, then it is strong acid. Let us take some acids and see. Strong acid. So lower the pKa value of an acid, stronger the acid. Yes, students. So this equation derivative I have already explained in another video. Please go through that acidity of carboxylic acids video, Venus Academy. Right? Anyhow, so the pKa values are inversely proportional to the pKa acidic strength. Let us take some acids and see. Yes, students, let us take some acids and see the acidic strength. So the key point here to remember is lower the pKa value, stronger the acid. Yes, for example, if I take HCl, which is inorganic acid, and its pKa value is about -7, so it is strong acid, low pKa value, and the carboxylic acid, trifluoroacetic acid, if I take trifluoroacetic acid, its pKa value is 0.23, and when it comes to benzoic acid, it is 4.19, and when it comes to acetic acid, its pKa value is 4.26, 4.76. That means the lower the pKa value, stronger the acid. This is strong acid. Strong acid, weak acid. Yes. So carboxylic acids are moderately strong acids, where substituted carboxylic acid like this strong withdrawing group containing carboxylic acids are going to be strong acids, and this is weak acid. Yes, Yadav, I am repeating this acidic strength, right? So previous to this, just now I completed the derivation of pKa equation. So anyhow, detailed derivation is available at acidity of carboxylic acids at Venus Academy. Please type like this: acidity of carboxylic acids, Venus Academy. In that I have explained the detail, right? Just now we derived the equation of pKa, right? Let me explain. So lower the pKa value, stronger the acid, and in overall organic molecules, carboxylic acids are going to have pKa value from 0 to 5. So these are strong acids with respect to organic compounds. These are strong acids. pKa is 0 to 5. Then followed by phenols. So unsubstituted phenols are going to have around 10. pKa is around 10. And this followed by water. So water is inorganic, it is not supposed to be mentioned here, its pKa is 14, right? Then follows alcohols, it is about 15. That means the carboxylic acids having pKa value 0 to 5 are strong acids, and phenols are moderately strong, and water is not neutral, and alcohols are very weak acids. So this is how acidic strength can be explained based on pKa value, right? Then what are the affecting or substituent effect? Is there any effect on acidity of carboxylic acids? Yes, let us see. So please pay the attention, students. Substituent effect on acidic strength of, it is always you are getting at least one question in NEET as well as JEE. So mention which is stronger or weaker acid strength. So all you have to know is what are the influencing groups, what are the effects of this. So I can say electron withdrawing groups. Right? So electron withdrawing groups enhances the acidic strength, whereas electron donating groups lowers the acidic strength. It is very simple, students. So what is happening? The anion which is there, if there is someone to share that O minus, and if it is electron withdrawing group, then it is going to be stable. So it easily loses H plus ions and it is going to be stable. So electron withdrawing groups enhances acidic strength, and electron donating groups lower the acidic strength. For example, the electron withdrawing groups, suppose nitro group, right? CF3 group, like that. And there is an order where you can find the electron donating or withdrawing groups, how it is going to affect. Let me take the order. So usual, if it is substituted with trifluoromethyl group, it is going to be strong acid, trifluoroacetic acid, and followed by nitro group, followed by cyanide group, followed by fluorine, chlorine, bromine, iodine, and followed by phenyl or benzylic or allyl group or hydrogen. Then follows electron donating group. For example, electron donating group methoxy group is electron donating group, right? So if I take one simple acid, I will take one simple acid CF3, same acid OH, trifluoroacetic acid is more strong acid, then please write down this. You don't have this in your textbooks. So nitroacetic acid, among these two, which is more strong? This is more strong, followed by cyanoacetic acid, Same example I am writing, students. And if it is fluoro acetic acid, then followed by chloro. It has been asked so many times, that is why I am writing chloro acetic acid, followed by bromo acetic acid, followed by iodoacetic acid. So this is the place where you may make a mistake, iodo or bromo, right? So please remember fluoro, chloro, bromo, iodoacetic acid, weak acid compared to bromo. Then phenyl acetic acid, yes. So this is order, students. Then allyl is CH2 double bond CH. This is allyl acetic acid, allyl acid, and followed by formic acid. Yes. So this is the way the influencing group or electron withdrawing groups are going to have effect on carboxylic acid strength. That means this is strong acid and it is weak acid. So let us take some examples and see the acidic order. Trifluoroacetic acid followed by trichloroacetic acid followed by CHCl2 followed by nitroacetic acid, same thing, followed by cyanoacetic acid, followed by fluoroacetic acid, followed by chloroacetic acid. These are very, very important, friends, to understand. Bromoacetic acid, followed by formic acid, followed by now it comes, students. So your idea, where CH2 then CH2, it is substituted at beta carbon. If it is substituted at beta carbon, chloroacetic acid, right? Followed by benzoic acid, followed by phenylacetic acid, followed by acetic acid, followed by propionic acid. Yes, methyl group. So the important thing here to remember is how the fluorine, chlorine, bromine and iodo is going to have effect on acidic strength. Yes. So this is how the more the halogen is substituted at alpha carbon, you may get this type of halogen, or you may have this compound CF3. If I write CF3, CH2 and COOH, and you may get chlorine trichloroacetic acid. Let me know which is more stronger among these two. Yes, student. So this is more stronger. Trichloro, alpha carbon, the carbon which is attached to carboxylic acid is going to have direct effect on this carboxylate ion. That is why the oxygen O- is going to be more stronger if it is attached to withdrawing group directly. This is going to have, it is beta carbon. This is alpha and this is beta carbon with respect to carboxylic acid. So you have to stress this type of examples. Otherwise, so benzylic and allylic. Why allyl group is going to have effect on acidic strength? Let us see. So usually we, and this question comes in JEE or NEET exam type questions, entrance exam, CH2CH COOH, and usually this substituent is going to have increase the acidic strength, right? So it is electron donating group. Actually it is electron donating group, though it is going to have different effect on acidic strength. So presence of, please write down, presence of allyl group increases the acidic strength. How? It is because of resonance stabilization. It can resonance stabilize this carbanion. It is going to have double bond and this O minus and OH. Yes, it is going to have this resonance stabilization. So because of this resonance stabilization, it is going to have two resonance forms. So because of this resonance formation, resonance stabilization, allyl group containing carboxylic acids are stronger than, suppose here it is strong acid than CH3, CH2, propionic acid. Yes, allyl, this vinyl acetic acid is more stronger than propionic acid. This way I can say vinyl acetic acid is more stronger than this propionic acid, or the common name is other acrylic acid, right? So it is stronger than this propionic acid. This is how the substituent effect is going to have effect on acidic strength. Yes, students. Let us take some examples and see. For example, if it is benzoic acid, and substituted with nitro group. So substituent which is having electron withdrawing group on benzene ring, this para and ortho are going to have strong acids. So its pKa is 3.41. So it is strong acid when compared to benzoic acid. What is the pK of benzoic acid? It is 4.19, and when you compare this acid with para-methoxybenzoic acid, so methoxy group is going to have electron donating group, its pKa is 4.46. So this is strong acid and it is weak acid. If I give this acid trinitrobenzoic acid, it is not picric acid. Trinitrobenzoic acid, is it weak acid or strong acid? Yes, it is one of the strong of aromatic compounds. So here it comes. So trinitrobenzoic acid going to be strong acid, then only one nitrobenzoic acid and benzoic acid and methoxybenzoic acid. This is how acidity of acids can be influenced by substituent. Yes, students. Let us take the chemical reactions based on the functional group. Yes, students. Let us take one by one chemical reactions. The first one is esterification. I am going to stress on important things. So esterification, let us take carboxylic acid plus alcohol. Let me take ethanol, CH3, CH2, OH, and if I do the esterification in presence of acid, H plus ions, I am going to get R O, and this is the alcohol part is going to be attached. This is the key point. So oxygen is coming from alcohol. Oxygen is coming from alcohol. During cleavage, this oxygen is going with alcohol and this oxygen is coming from alcohol part. This is ester. The name is ester. If I write the mechanism, so when I write H plus ions, carboxylic acid, yes, it will have lone pair electrons. Dear students, it also will have lone pair electrons. So the oxygen which is sp2 hybridized is going to share its lone pair electron more easily than the oxygen having sp3 hybridization. So it easily donates lone pair electrons to form R, O, H is here, positive charge, and OH. Yes, now it is going to take up, we are doing, let us say in water, sorry. So now it is going to take up alcohol. Let me write ROH here, and this OH is going to attack onto the carbon on the oxonium carbon, oxonium ion to give RCOH, and already this OH is here. I am writing down this OH. Now O, R and hydrogen is here. Yes, so what is the hybridization here? It is sp3 hybridized carbon now, tetrahedral. This is sp2 carbon. This sp3, it exchanges, proton exchange takes place, proton exchange, where it is having this proton will be exchanged by this oxygen to give an intermediate where R, O, positive charge, and O, R. Now it is very easy. It loses H plus, and to give R, O, double bond O, and O, R. Yes, students. So minus water. This is nothing but ester. So the mechanism, key thing is that the oxygen which is coming here is from alcohol part. So I can write alcohol part. So if it is labeled with oxygen isotope, then it will be here. So this is what you have to remember. So this oxygen is coming from alcohol part. Okay, Yadav. So acid upon reaction with alcohol gives esters, and the oxygen part is coming from alcohol part. Right, students? So the hybridization, when you see the hybridization of this carboxylic acid sp2, so it easily forms sp3 hybridization to get out of strain. So it easily takes up proton to form this oxonium ion. Oxonium ion takes up this alcohol oxygen to give this intermediate where it proton exchanges. Yes, or I can write in different form. So it loses this, it gives intermediate, no doubt, it gives intermediate ether, and it takes up proton, any one of these two, and it is going to form this same intermediate. Right? Same intermediate. Now it is going to lose water to give ester. Right, students? Let us take some examples under this. So I can take, if I take benzoic acid, you will be tested on this part mainly. and alcohol, ethanol, I can write like this, ethanol and acid. And moreover, this reaction is reversible reaction. As soon as the ester is formed, you have to remove off this ester, or you have to take care that water should not present. Otherwise, it is going to hydrolyze back. Yes, there are techniques to use beanstalk apparatus and like that, and it is synthetic techniques. Don't worry. So at this stage, use H plus ions and see that ester and there should be no water. So you should not write water here. If it is water, it is backward reaction. So this is going to form ethyl benzoate. Like this, you are going to get esters. Right, students? Next. Then reaction with phosphorus pentachloride or phosphorus trichloride or thionyl chloride. So during alcohols part, we have come across this type of reaction where OH group is going to be substituted with halogen. In alcohols, we have seen that halogen. Yes, students. In alcohol part. Similarly, when I take this carboxylic acid, I am going to get acyl halide. Carboxylic acid. In presence of these reagents, any one of these reagents, I am going to get acyl halide. So among these, if I use PCl5, for example, carboxylic acid, if I use PCl5, phosphorus pentachloride, I am going to get RCOCl plus POCl3. Plus HCl. Yes, students. Or if I use same acid plus PCl3 or PBr3, I can use PBr3 also. However, that PBr3 if I use, there is another reaction it is going to undergo. So PCl3, let us stick on to this PCl3, RCOCl plus this phosphorus PO H3 PO3 plus it is going to form H3PO3. However, the removal of POCl3 it is very lacrimatory, means your eyes will what I can say. So tears will come, right? So it is lacrimatory. Use of this PCl5 and PCl3 will be lacrimatory. So it is very tough to handle this type of reactions in laboratory. So the easiest method or the best method to make acyl halides is use of thionyl chloride. Thionyl chloride is a liquid, and when I treat this thionyl chloride with acid part with thionyl chloride, I am going to get acid chloride RCOCl plus sulfur dioxide, which is volatile and it is not going to stay in the reaction mixture, and HCl, which is also going to be out as gas. HCl gas. Right, students? So carboxylic acid in presence of thionyl chloride, you are going to get acid chloride, and the other sulfur part is going to be as sulfur dioxide and it is going to be HCl. These two are volatile, and simply I can get this acid chloride and use it for other reactions. So this is how reaction with phosphorus halogens is going to form acid halides. Next. Yes, students. Next, reaction with ammonia. So ammonia is a base and it is an acid. What is going to form? It is going to form first salt, then it is going to form amide. For example, if I take acid plus ammonia, it is going to form RCOO NH4 plus and minus, and this when I heat it, it is going to lose water and to give amide NH2. So this is amide strength. Write down amide. For example, if I take acetic acid and treat it with ammonia, I am going to get this salt ammonium acetate. It is a buffer. Ammonium acetate, it is a solid part. Ammonium acetate is a buffer solid where it is a salt of weak acid and weak base. So it is going to be act as buffer. Ammonium acetate, when I heat it, it is going to lose water to form acetamide. This is acetamide. Similarly, if I take benzoic acid and treat it with ammonia, I am going to get ammonium benzoate, and this ammonium benzoate upon heating it loses water to give benzamide. And important thing, Gabriel amino acid synthesis, you will learn this. Phthalic acid, where we prepare from tetralone, this phthalic acid upon reaction with 2 moles of ammonia, it is going to get salt of this phthalic acid, and this upon heating it is going to form amide, diamide. So this from this phthalic amide, phthalamide, this is phthalamide. Spelling is important, students. Phthalamide. This phthalamide upon vigorous heating in presence of base, it is going to lose 1 mole of this hydrogen ammonia. At high temperature it is going to lose minus ammonia to get phthalimide. This phthalimide plays a very important role in Gabriel amino acid synthesis. So during that synthesis or the name reaction I am going to explain this importance. So this is phthalimide. Write down the spelling. Phthalimide. Yes, students. So phthalimide you are going to get. Next. So reaction with ammonia. So this is how you can get amides from acids simply by using ammonia. Let us take next reaction. Next is a reduction. It is very important to learn this, students. So what is reduction? Again, if I write Leoger, so it says letting of electrons oxidation, gaining of electrons is reduction. With our context, it is addition of hydrogen is reduction. Addition of oxygen is oxidation. Addition of hydrogen is reduction. Let us take carboxylic acid This is carboxylic acid. When I do the reduction with lithium aluminum hydride, it is going to reduce or it is going to add two hydrogens to give alcohol. Yes? So this lithium aluminum hydride, when it comes to chemoselectivity, means this lithium aluminum hydride is going to reduce all types of compounds like carbonyl compounds, nitro to amine, esters. So LAH is not selective. It is not selective reducing agent. It will reduce ketone, aldehydes, nitro, esters, and all these groups are going to be reduced to alcohols or amines. Yes? So in your starting material, if you are doing some synthetic part, in your starting material, imagine that there is an nitro compound, for example, CH2, nitro and COOH, and you are in need of this compound, and halogen also. Halogen also reduces this LAH. And nitro, you are in need of this compound. What is the reagent? Optional reagent. Yes? So there is one reagent where nitro, ester or halogen. So nitro, ester or halogen are going to be no effect or intact. The reagent is diborane B2H6. Dear students, please remember, diborane is very important reagent which is chemoselective. Means it chemoselectively reduces only acid to alcohol. Acid to alcohol. Yes? So acid to alcohol, it is asked in NEET, students. So diborane was asked during 2018 NEET. So diborane can be used for the reduction of acid to alcohol. It is chemoselective. So diborane is nothing but the structure BH3 and BH3. You will get BH3 like this. Yes, diborane. It is dimer of borane. So this diborane, however, it is costly and very tough to handle in synthetic chemistry. But if you are in need of this specific compounds, this reduction of only acid is required. You have to use diborane. Yes, if I use lithium aluminum hydride, what is going to happen? Any guess? So this compound is going to be amino alcohol. Right? But I am in need of this nitro. So here diborane comes. And one more, the common reagent what we learned is sodium borohydride. Sodium borohydride is not going to work or not going to reduce these carboxylic acids to alcohols. Yes, students. So this is how reduction of carboxylic acids chemoselectively done by diborane, whereas lithium aluminum hydride reduces carboxylic acids to alcohols, but the selectivity is very low with respect to other functional groups also are going to be reduced to different compounds, suppose carbonyl compounds alcohols, nitro to amine, ester to alcohols. So diborane is key point, please remember this, students. Next is decarboxylation. Decarboxylation of carboxylic acids. So when I treat acid with base or soda lime. Soda lime is a mixture of NaOH plus calcium oxide in 3:1 is known as soda lime. You make it as soda lime. Right? So this soda lime is going to form first, say this is ONA, and this sodium salt, when I heat it, it is going to lose carbon dioxide. So this carbon dioxide is going out and you are going to get alkane. So decarboxylation takes place. Dear students, most of the times Even simple heating also decarboxylation takes place. For example, benzoic acid, thermal decarboxylation is known strengths. So it loses carbon dioxide, right? So you may get only heating also, you have to write benzene, carboxylic acid loses carboxylic acid. So decarboxylation is known. Another decarboxylation method what we learnt in previous class is Kolb's electrolysis. So in this it is a free radical reaction where if I take 2 moles of, for example, CS3 acetic acid and do electrolysis, I am going to get ethane. CS3 O, it is minus and plus, O minus, and it takes up electrons, 2 electrons, it is 2 moles, CS3 minus 2 electrons. The 2 electrons if I remove from here, or let me write 1 electron minus, it is going to form CS3 CO free radical. This free radical further in next step it is going to form methyl radical plus carbon dioxide. This methyl radical, it is methyl free radical plus another methyl free radical is going to form ethane. Yes students, next, so at cathode what is going to happen, water is going to be there plus, and the electron which is coming here will take up this and form OH minus and H free radical, and 2 H free radicals is going to form hydrogen. This is how it is going to undergo decarboxylation. The usual method is soda lime. Soda lime method is very common students. So carboxylic salts, under using soda lime it is going to lose carbon dioxide. Next, so next is substitution reactions on alpha carbon of carboxylic acid, right? So what is alpha carbon? R CH, and this is alpha carbon, and this alpha carbon hydrogen will be substituted in presence of halogen, let us write chlorine or bromine, in red phosphorus. Using red phosphorus it is going to give alpha halo carboxylic acid. So X can be chlorine or bromine, and this alpha halo carboxylic acids are very important synthetic starting materials for the preparation of amino acids, right? So this reaction is known as Volhard-Zelensky reaction. Dear students, I have made already name reactions. Under name reactions, HVZ reaction, there I have explained in detail mechanism and number of examples. Anyhow, at this stage the mechanism follows like this. The red phosphorus, what is there, phosphorus will react with bromine from PbR3. Yes, PbR3. This PbR3 is going to act real reagent for the halogenation of alpha carbon. So the acid group what I am going to take, this PbR3, it is observed that it, even if I use PbR3, it is going to form alpha halogen. In previous example, PCl3 examples we have seen. So it is going to form, first it is going to form this acyl bromide. Why this mechanism is taken? Because acyl bromides even without using phosphorus are going to give alpha halo bromo compounds, alpha halo carboxylic acids. This acyl bromide So these acyl bromides can enolize to form R C hydrogen double bond CO and bromide. Enolized carbon. This enolized one, it will take up bromine. Since we are adding bromine, so it takes up bromine to give R C hydrogen. No new bromine has come here. O double bond O bromine. So this dihalo compound is going to react with another mole of this carboxylic acid to exchange this bromine with this water to give OH group to give R H bromine and COOH, and again this acyl bromide, and it will be recycled in the reaction mixture. So acyl bromide will be formed, and the product is alpha halo carboxylic acid, which is the product of HVZ product. So L Vollard-Zelensky reaction gives alpha halo carboxylic acids. Next, benzoic acid. What is the nature of this benzoic acid? Is it electron withdrawing or donating? It is electron withdrawing group. It withdraws electron density or these electrons from benzene ring. So it is electron withdrawing group. This electron withdrawing group is deactivating group. Electron withdrawing groups are deactivating groups. Deactivating groups on aromatic ring, they orient the incoming electrophile to meta position. These are meta directing group. Carboxylic acids are meta directing groups. Since it is a carboxylic acid, it is very important, students. Friedel Crafts alkylation or acylation is not going to take place. Friedel Crafts reaction are not done on carboxylic acids. Why? It easily loses H plus ions. We are going to use dry aluminium chloride. This dry aluminium chloride is going to form complex with carboxylic acids because it gives H plus ions. So further it will not move forward because it forms salt with carboxylic acid. So that is why Friedel Crafts alkylation is not going to be done, right? So, and one more, already I have explained, nitro compounds also you are not going to use in Friedel Crafts reaction. It is also not going to undergo Friedel Crafts reaction. That I have explained under Friedel Crafts acylation and alkylation reaction, students. So why it is withdrawing group, that is why it is not going to undergo Friedel Crafts reaction. So it can be used as solvent. Nitrobenzene is used as solvent in Friedel Crafts alkylation reaction. Anyhow, so benzoic acid part, let us take some reactions. Nitration. So nitration reaction of aromatic ring is aromatic electrophilic substitution reaction. Yes, students. So aromatic electrophilic substitution reaction. So benzoic acid upon reacting with HNO3 and sulfuric acid, I am going to get meta-nitrobenzoic acid. So if you are asked to make meta-nitrobenzoic acid, don't write this acylation reaction or carboxylation, nitro to this. So do the nitration. What are the steps involved as usual? So HNO3 and H2SO4 plus HNO3 is going to form HSO4 minus plus OH. It is going to give H plus ions. Here it is going to form positive O, and this is O minus, and it loses NO2 plus. This is electrophile. Generation of electrophile takes place, and this electrophile will take up this, will substitute this metal hydrogen, and at the final stage it loses hydrogen to this sulfate ion to give sulfuric acid back, and it is going to be substituted with nitro. Yes, similarly halogen also, bromine, in presence of ferric bromide, it forms, for example, bromine electrophile, students. Ferric bromide, it is a Lewis acid, it is going to form bromine plus ferric bromine taken 4 times minus, iron minus. So this electrophile, if I take same benzoic acid and do the bromination, bromine in presence of ferric bromide, I am going to get metabromo benzoic acid or 3-bromo benzoic acid we are going to get. So this is how we can do electrophilic aromatic substitution on carboxylic acids, aryl carboxylic acid. Yes, students. So let us take some uses of carboxylic acids. What are the uses? So some of the carboxylic acids, if I take formic acid, it is used in textile industry, right? Rubber industry or polymer industry, and the important thing is acetic acid. This is vinegar. What is vinegar? Food additive. Yes, food additive. And important thing is, if I use this sodium benzoate, what I prepare during salt formation is food preservative. So you will find this sodium benzoate in some food particles as a solid part, or you will get in a bag of this sodium benzoate too, which prevents from oxidation. And especially this hexanoic acid, at the beginning I have explained this hexanoic acid, adipic acid, hexane dicarboxylic acid, adipic acid is useful for the preparation of nylon 6,6. It is a polymer. Nylon 6,6 is a polymer. It is useful. And esters, yes, can be used as perfumes. Esters as perfumes. And moreover, the large number of carboxylic acids you come across are fatty acids. These fatty acids, glycerol esters, fatty acids, glycerol esters are soaps and detergents. Yes, friends, these are some common uses of carboxylic acids. Dear students, I hope you enjoyed this lecture. We will meet again with NCERT exercises based on these aldehydes, ketones and carboxylic acids. Thank you, students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with new topic. Till then, bye. Arigato gozaimasu. Thank you. All the best. Thank you, students.